Okay, can everyone hear me okay?
Sure. Yep.
I feel like this is like picking it up okay from the back, right? Can I get a thumbs up in the back? Great. All right, cool. So this is JavaScript and parallel processing. Huh? I don't know what that sounds like exactly, but you know what I mean. Okay, we're excited, but a little confused. So if you're in the wrong room, totally leave right now. That's fine. Or you can leave in the middle. That's also fine. And let's just get started. So first of all, quick intro. My name is Joe Carlson. Let's see here. You've caught me at a weird time in my life. So I'm giving a bunch of front end talks, but I just started working at MongoDB on Monday. So that's 3 days ago. And I've been working as a developer advocate for them. Previously though, 2 weeks ago, I was the technical lead on bestbuy.com and worked doing mostly front end work, React, JavaScript, et cetera, full stack stuff. Yes, so I've been teaching JavaScript for many, many years, and I love it, and this is what I love. So yeah, that's my website. If you want to contact me, go ahead. I would suggest following me on Twitter. So I'll be posting resources, links to the slides, code samples, et cetera on there too. Also, as an added perk, I also tweet a lot about front-end stuff, performance. I'll be posting obviously a lot more about MongoDB, NoSQL databases as well. And I talk a lot about diversity, inclusion, and making tech a more sane place to be. So anyway, if that interests you, you should totally check that out. So, okay, great. I always like starting out my talks with moving my water bottle. My talks, I tend to do these a little more informally. If you have a question, feel free to just ask it in the moment. I think it's more, it doesn't throw me off my game, doesn't throw off my flow. I think it's more fun to kind of engage too. And I like addressing questions like while we're in it. We will have time at the end for questions. And I will, of course, be available in the boot to talk about anything. So, cool. Let's see here. Other note, I've given this talk a couple times. Last time I gave it, the nature of this is like we're going to be pushing my computer to the limit with running multiple threads. It crashed my computer last time I ran this, so bear with me if that happens. We'll figure it out together. So, cool. I'm also recording this talk too, so I'll be posting this on my YouTube channel and Twitter later on too. So if you have whatever, you can find that too. Okay. Great, let's get into it. So, first of all, so threads. Does anyone know what a thread is? I'm talking about parallel processing here. Threads. I know also this is like end of the day too. This is like, I'm like the last session for the closing keynote. Everyone's brain's probably really full. I'm gonna try to keep people at least awake. Threads. What about anyone heard of a quad core, dual core? Snapdragon, yeah, right? We've all heard those things, right? So what that means basically is quad core means there's 4 CPUs on a chip, and that allows you to run 4 concurrent threads. And there's other things like hyperthreading and all that stuff too we're not going to get into. Yeah, that's what threading is, right? It's like you're able to utilize multiple threads to do things faster, so you can split up the work. But JavaScript is a single-threaded language. Which means it is traditionally not possible to run it across multiple threads. Does anyone know of any other programming languages that are multiple threaded? Just yell them out. What's another language you worked with that allows multiple threads? Go. Julia? Is that what I heard? Cool, yep. Any other ones? Java. Java's a big one. Probably heard of that one. Yep, so those are languages. Ruby, Python allows you to do that too. Actually, most programming languages do allow you to use multiple threads. But JavaScript was designed to work on a single thread. And there's actually a lot of really good reasons for that. So why was JavaScript first designed to work on a single thread? And I think that this stuff's important too. When you're evaluating a language to write your next project in, understanding the pros and cons of it, I think is really important for picking a language out, right? I hate language wars, like my language is better than yours. It's like different languages are designed for different tasks, and you should understand when and when not to use those. And understanding when JavaScript, why it's single-threaded, helps you better evaluate when to select that as your programming language for your next project. So, why exactly is JavaScript single-threaded? Well, there's a bunch of reasons. First of all, single-threading is really easy. Well, it's easier to program than multiple threads. who's in a multiple, when they're doing multiple threading or concurrency, run into like, what's it called? Like a race condition, or like some locks, or maybe accessing data before it's ready and it's not actually there yet. Then we never encounter these such things. Yep, that stuff, it's hard to reproduce because it's really dependent on your machine, so it can be hard to debug. And also, your brain has to start thinking differently, because when we're programming, we see things like this is done, then this is done, and this is done. When you get into multiple threads, it may not actually be done yet, right? So single threading can make programming easier to do, right? So that helps. Easier to debug, as I mentioned before too, right? Like debugging, that stuff can be really challenging because it's dependent on what other resources in your computer are utilizing the CPU at the time. So it may work one time and then the race condition may not see that ever again, right? That can be really hard. So it's really easy to port single threaded code because it works on any CPU. The hard part with like GPU code, so if you're like, for example, like graphics cards, what it's doing is it splits out its processes into like 1,000 different branches to let each GPU handle that differently. But I can't port that code to another piece of hardware that doesn't have that GPU to allow you to do like split that up so concurrently. But single-threaded code, I can move anywhere. I could put that on a Raspberry Pi. I could put that on a low embedded device. I could put that on my laptop. I can put that on a gigantic cloud server. You can put that anywhere. It's going to work. And this one, you'll notice it runs faster than multi-threads, but there's a big asterisk here. And I think this is important to note for JavaScript and Node in particular. So you may have heard Node is really fast. Node runs on a single-threaded event loop, and it's really fast under certain conditions. Does anyone know what those conditions are? When does Node or single-threaded languages really slam dunk the competition? I'll just give you the answer. That's okay. It's quiet. It's just like sleepy nap time. It's fine. I won't judge. So Node and JavaScript are really good at handling really fast I/O. So non-data intensive I/O operations. So Node works really well for like chat services or Twitch or streaming. Just comes in, goes out. Maybe you're doing a little bit of data processing, maybe modifying that request a little bit. You're not doing anything too intense. So for example, if I was writing like a tax software that was doing some massive calculations on some, doing a bunch of, determining my tax I owe or something like that, like I may not want to use Node because that's going to be really intensive and that's going to block the main thread. If you're blocking the main thread, that's going to become really slow. But if you can just in and out, you're golden. Node and JavaScript is amazing for that. So again, when you're picking out a language for your next project, understanding the type of I/O you have on that is really important for determining what language you want to pick. That's going to best be optimized for the type of work you're doing. Okay, did I have another one? And lastly, single threads can do anything a multiple thread can do. It just does it a little bit slower. So the difference is we can't break that work up and have different CPUs handle that work concurrently. But it can still do it. It's got to handle it on the single thread. Cool. So there's actually a lot of great reasons why single threading is awesome. Personally, I also think that single threading makes JavaScript a really great language for people new to programming. And any language you can not get into the threads too, but I don't know. That's one less thing you have to worry about when you're programming with a single-threaded framework or language. Okay, so single threads, they're awesome. There's a ton of perks to them. They're really great. But what's the problem? My slide transitions are kind of slow. It's throwing off my game here. So what's the problem? I'm trying to do like a Big Lebowski theme yet. I don't know. It feels like whatever. Okay, so whatever. We go on. The problem with JavaScript being a single-threaded language is that the single thread is shared with the browser. Okay? So what does that mean? What does that mean for us? So this way you might understand. This means if your CPU or that thread is being highly utilized, it means that it's going to block everything else. That thread is doing other work. So new work can't get done until that single thread gets cleared. That could be a problem. So what happens, and maybe it's a good time to demo. Let's do a demo here real fast. Blah, blah, blah. Just recently switched to Firefox. Okay, so I just want to do a quick little show and tell here. This is the demo that always breaks my computer, so cross my fingers here. What I have here, actually, maybe I'll just show you the code. Yep, we'll just show this real fast. So this is the code we're looking at. It's a simple web page. It's just a button. When I click that button, it's just going to run a gigantic for loop. I don't even know how many zeros it has in it. A lot. But the point is that's going to block the main thread when it's running that. And what happens is, while that for loop is still running in the background, all the other user interaction totally stopped. I can't do anything. You'll also note I have that second input there is a button that runs the alert, which I don't know if I have on there. Yep. It runs an alert that should say like hello or whatever when I click it. So let's see what happens. I'm gonna run this. Where's my mouse? There she is. All right, so big loop, running it, and I'm clicking, say hello, and nothing's happening until that event loop, that main loop gets unblocked. And there we go. Now it finally gets unblocked, and the user interaction is finally being parsed by that single thread. So it's completed all of them, and then finally, once it completes, then we can start seeing interaction in the browser. This could be a problem. As front-end engineers, we're creating user interfaces, and we want them to be usable. And if they're so expensive that the user can't use it, that's a problem. I don't want the user to have to wait for my for loop to be done to be able to click a button or interact with the page at all. The entire web page is totally blocked because that main CPU thread is being shared with the browser. It's blocked. Okay, so back to this one, right? So if our CPU utilization, or that single thread that gets highly utilized, that means we're stuck, we're blocked, we can't do anything. So for loops take a lot of time, but there's also a lot of other things in the browser that take a lot of time. Let's see here. Does anyone know? What would be some, or guess, any guesses? Dumb answers are totally acceptable here. Painting, yep. Yeah, doing like expensive CSS stuff, yep, absolutely. Any other guesses?
Processing large data sets are out there.
Yes, yep, that's actually my first one on here, yep. So something that we do a lot as front-end engineers is we're consuming data from some back-end API. Oftentimes we're getting, paginated data sets, so we're only getting like 10 at a time. But that's not always the case. Sometimes I get data sets that have thousands of items in them. Let's see here. I think, Jeremy, you had an example where you had downloaded like a gigabyte JSON or something?
This is like back in 2009. It was for a healthcare employer like UHG.
Yeah.
They had a job site, and they were sending down about 2 megs of JSON, and we had to process it all on the client. That's what they wanted.
Yeah, up front.
Up front, it would block the main thread for about 10 to 15 seconds.
It's rare, and if that happens, right, and I think Jeremy even insisted, like, we shouldn't do this, and then product was like, no, we're doing this, sorry. That happens sometimes, right, and it blocks it. But yeah, that processing large data sets can take a long time, especially if it's huge. The other thing, too, that is common in the browser is image processing. So for example, maybe you're doing some pre-processing on an image before you send that to a server. Maybe you're doing like a quick edge detection software, or scanning some bits, or converting it to a different tone or different data type or something in the browser. That can be really expensive. Relatedly, sound is also, like audio, there's a new audio API, that can be really expensive, and then video processing is also going to be really expensive by the browser as well. And the last one too is doing real-time analytics. If you're doing stuff that's constantly utilizing that main thread, that can also be really expensive for you. So the point is, there's actually a lot of things that we do that could be potentially really expensive for us, and could block that main thread, become an issue. So I already showed you this one. This is our example of a thing. I've run this too. I've actually done some image processing. I wrote an edge detection software for the browser, and what it did, it scanned every pixel and made a guess of what the edges look like on there. That ended up blocking the main thread too, and I actually had to utilize this method we're going to be talking about today to unblock it. So, oh yeah, this is a GIF. I always have fallback GIFs in case. We'll just watch it again. You can tell by I'm shaking it out of frustration. It's because the main thread is locked here. We'll check this out again. We saw this. It's fine. Okay. So this is bad on my MacBook. This is a MacBook Pro 2019, brand new, and I'm running a for loop, and it still blocked my thread. This is even worse on mobile devices. Like, I have the iPhone that has, like, I don't know, some fancy quad-core Snapdragon thing. I don't even know, but yeah, right. And even that's fancy. Like, users are using 10-year-old Android devices or whatever. Like, that sucks, right? You're making an even worse experience for people on mobile. Okay, so this could be a problem, but how do we deal with it? So I want to talk about, let's see here, I don't want to talk about the new way we did this. Do people know where this talk's going? We're talking about web workers today. Does anyone know what we did before web workers existed? Is that timeouts? Yeah. So that would hack it to get off the main thread. Yep, that's true. Another thing that I did too was we would offload CPU intensive processes to a server. So for example, we're doing image processing. I wouldn't do that in the browser. I would send it off to a server to do that processing and get that data sent back, which isn't a bad way to do that. Set timeout's also a great way to do it too. Very hacky, right? But I do want to share this with you because I think it's really important. This is Google's numbers everyone should know. Every developer should know. If you haven't seen this before, I would suggest Googling it. These are really important, especially if you're like a lead or architect for kind of understanding where you want to put processes on a system. But I want you to note, let's see, where's my mouse? Don't have a mouse. Okay, I have a pointer. First thing I want you to notice is at the top are the fastest processes. Hey, there we go. We have our fast processes up here on the top. If we can do this process on our computer locally, that's going to be much faster for us to get back and it's going to be a better customer experience. If we can minimize the amount of time. But, let's see here, if we have to send that packet from California to Netherlands and back again, that takes much, much longer than having to do that just locally on your machine. So the point is, right, with this is that we used to send it to clients or send that to a server to be done, but if we could do that locally, that's going to save our users a bunch of time. That's a better customer experience if we can handle it on the local machine. All right, cool. So, old way, we used to send it to servers, do CPU-intensive processes, but now we have a new way, and that's web workers, baby. So web workers are native. I don't even know. Every browser supports it. I think it's been around since, I don't know. It's been a while. It's been around for years. It's universally adopted. Totally native. You don't need any extra libraries. You have it for free. But it allows you to do multiple threads in the browser. It's so weird. It's been around forever, and like no one really knows about it. And everyone, I was even telling people yesterday I was doing this talk about multiple threads with JavaScript, and people still don't believe me. But this is free today for you to use this. This is great. So web workers. Basically, what are web workers? Web workers allow you to run scripts in the background on a different thread than your main thread. It allows us to do multiple threading in the browser with JavaScript. What am I looking at? So web workers are faster. They are more responsive. They're more battery efficient than sending things out. Opening up a data channel, sending it out, and it's supported in every browser. Here we go, in IE 10+. Okay, cool. So web workers, fast, local, great. But there's a couple gotchas. So we're going to be talking about what they are, how to use them, and also the gotchas. There's some weird things with web workers that you should be aware of if you're going to be considering using them on your project. So, first of all, weird thing numero uno is web workers cannot access your the window of the DOM object directly. So if you cannot do DOM manipulation from a thread. You have to do them via the main thread. You have access to everything else that a regular thread can do, every JavaScript method, every array method. You have access to all that stuff except for the window and the DOM. Yeah, let's take a look at how web workers work, and then I'll kind of show you how that works. So first of all, If you want to instantiate a brand new web worker, all you do is just run new worker and then the file that you want to run in a separate thread. Each worker you create is a brand new thread, so you can create as many as you want. Let's see here. I'm going to show you. Let's do another little live demo here. We got our thing here. I was going to save this for the end, but I feel like it's more appropriate now. Actually, you know what I'm going to do is open this in. I just switched to Chrome this week because of weird privacy stuff with or switched to Firefox this week because of weird privacy stuff with Chrome. But I'm also not as good at using Firefox yet, so I'm just going to do this the good old way. All right, 1 second. Okay, great. Okay, so this is a cooler program. I did not write this. I'm not sure who did. Pharos, I think he's on GitHub. I found this on GitHub. But what this is actually a web-based password cracker utilizing web workers to do it, crack passwords faster. If I was actually writing a real password cracker, I probably wouldn't use a browser, but right, proof of concept, right? So a couple things I want you to actually take a look at here. Each of these boxes is a separate thread that's being opened up concurrently. And you can actually take a look at this in real time here. So let's see here. Is it under this one? Nope. Oh yeah, it should open up here. So what I'm gonna do is refresh this. And, yeah, so we see here, actually in Chrome DevTools, it shows you the separate threads that are running at that time. So you can see here, of course, we have the main thread running, but as this runs, it's instantiating 8 separate worker instances on separate threads on this machine. You can see those working in real time. And you can actually dig into the call stack of each of those threads independently. Cool. So just a little GIF of that working too. Okay, great. So we can instantiate and use that new worker. But the key is what we do in JavaScript is you're instantiating brand new threads, and what you do is those threads do their work, and then you have them communicate back to the main thread. The main thread is like your central hub that's organizing all the separate other threads' work. So that will kind of monitor who's doing what, when things are coming back, and is capable of terminating any of the other threads being run out. And remember, your main thread is also the thing that's going to be responsible for making any changes to the DOM or the window. So how this works is they work via a message channel, and in your main thread, you're just listening for message events. So for example, in this one, we're doing an on message and an on error. So if any of the threads throw out a message, it'll be caught by the main thread, and we can watch that there. And all right, I'll tell you what, I think I'm going to show you. All right, let's take a look at some real code. This is the dude looking at our code here. Hope it's not that confusing. So in our workers, we're going to be creating message events. So actually, you know what? Maybe I'll just show you let's just look at the real code. Okay, so let's do. Okay, so I'm going to do a demo of this first, then we can show you the code. So this is actually a refactored code base where I'm using threads for the big loop. Instead of to instantiate the threads running the big fat loop, I'm just going to hit the start worker. Oh, that runs too fast. Too fast for us today. And let's make that bigger. Okay, refresh. There we go. So I can still run. I can still hit the button now while that big loop is running in the background. Okay, it's a big one. All right, still running a separate thread. Right, I have no idea how big that is, but that's going to run for a while. So let's take a look at this code. What does this look like? Okay, great. Ooh, this is really hard to read on here. We'll just make it big. Hope that's good enough here. So ignore this stuff. We'll get into this in a second. The important part I want you to look at is these. Well, let's take a look at the beginning here. So when we click the button Start Worker, that's going to run this function, and we're going to be instantiating a brand new worker of this file. And I've just moved this JavaScript file onto its separate little thing, so we can just run new workers on that when it runs. And then we have these messages. So these onMessage functions are callback functions that are waiting for messages being sent from this worker. So when this worker sends a message, this callback function gets triggered, and we can start parsing it. I have several different messages I'm listening for from my workers, and we can check that out next. So let's take a look at Big Loop. The Big Loop's pretty simple. All it is a for loop. But the key here too is every 5,000 times this iterates, I'm posting a brand new message back to the main thread, and then I also send another message back to the main thread when it completes. That's how I'm getting that status updates. That's that rolling counter on it as it's being posted up. And then I also can tell it when it's completed. So if we go back to that main thread, we can see that status. We're just updating the DOM, right? Because you can't access the DOM via worker thread. Just that main DOM, or that main thread, we can make updates to the DOM to kind of show status. And then once we get a complete function, I clear out that status and update the result saying that we're complete. I'm also running the stop worker function when that's completed. It's that main thread. Let's take a look at that one. We're telling we're at the main thread. We're telling that thread to terminate once we've got that completed message back from our threads. Okay, cool. Great. So this is kind of code, digging through it. And we'll just watch this GIF one more time too. As this is going too, does anyone have any questions so far? Threading. Yes. Yes, there is. And I think, let's see here. I think you can send that back. Let's see here. I think I did that. Let's see here. Where did I do that? Yes. And I can't remember how to do it. I'll have to look it up afterward. But you can post messages from the main thread to the worker threads too. Yes. Window.postMessage. Great.
There is a small library that simplifies some of that messaging.
Oh, interesting. It like kind of abstracts it away.
Yeah.
Cool. I haven't heard that. That's great. Yep. Great. Yes. Question.
Was the alert pausing the work?
No. It looked like it was, but it's the thread's still running in the background. It looked like the DOM was not updating while that was open. That must.
The alert would block the main thread, right?
Oh, it does. Oh, because the main thread's still responsible for making updates to the DOM. Yep, exactly. But that main thread should still be going. Yep. Thank you. Yes, question back. I think you have to feed it a file, as far as I know. I've been trying to figure that out too with like React or something like that. Yeah, I think you have to feed it as a whole, like a function or a file right now at this point. Yes. Okay, cool. All right. All right. Stopping web workers. All right, you tell them to go over the line. We already went over this too. You just have to run the worker.terminate. And you can terminate that from whether inside of the thread or from the main thread, either way. And you can see here too, big loop's running if I hit stop worker. Oh, there we go, hit it twice, but then it terminates that before it completes. All right, errors as well. Does anyone know how to like animate GIFs with like moving text? I haven't figured out how to do that yet. Do we have any like designers in the house? I just want that JS error text to fly with the mug as it goes across the screen, and I'm not that skilled of a slide master yet to figure out how to do that. Someday. As always, too, in the front end, anything can go wrong. It's always good to do error handling on those as well. So that's just listed the error events. I'm gonna skip through that. It's not kind of boring. But okay, this part I do think is really important. So like I said, browsers, IE 10 plus and all modern browsers support web workers, including mobile devices. But if you're thinking about implementing web workers on your application, I think it's still important to make sure that you're checking for support of that on the browser. Want to make sure that your browser is being very doodly in its handling of. So that one I could figure out. It's easy, just put a little text block over it. But how we're doing that is that fancy, that little if statement above it too. All we're doing is checking to see if the worker keyword is reserved and understood by the browser. If that's an object or class that the browser understands, right? If it's not undefined, then we can continue. That's basically all you have to do. And anytime I do put a web worker in my code, I do make sure I put just compatibility checks on it quickly too. The second if statement there too, I'm just making sure that worker has not already been defined for whatever reason. So if that worker has not been created yet, then I basically just am instantiating a brand new instance of worker in memory. And then you can start working with it. Okay, cool. Let's see here. And again, I have all this code on here too, all commented, et cetera, et cetera, et cetera. There's one question too I frequently get. And because we don't have access to the window of the DOM, which means if you put React or something onto the window or the DOM, you will not have access to it directly from a thread. But it is possible to import them. But you have to import them based on the in every thread that you need those libraries. So for example, if you want to start using Lodash or jQuery, or actually don't use jQuery because that's very DOM-y, but underscore or something like that, right? You want to make sure you're importing those into that function. And you can do that using this import scripts keyword, and you can just route to wherever that script you want to import into your library exists. And you can import as many as you want. Okay, cool. All right, a couple things. Yes, question in the back.
Does the new module syntax work?
New module syntax. Ooh, good question. I don't know, actually. Like using the new, like, are you talking about like imports or like, I do not know.
If anything's export,
You should be able to. Yeah, I'm not sure because I know that files work, but I don't know exactly about like bundled ES6 modules or something like that.
I know there's a webpack loader that can deal with this.
Yes.
So there may be some longer specific ones.
Yes, that's a good point. To kind of transpile it to work for that too. Yeah, that's actually a good point. There probably is that. So maybe like export it to like, but you could still use that as code, but wouldn't be able to use that natively. Yeah. Okay, so a couple of things I want to talk about here too. I want to talk about when not to use web workers, and I also want to talk about the future of web workers, because I actually think we're going to be needing to utilize threads more and more often as we expand what the browser and the web is capable of. So let's talk about the future first. So we're already seeing the things that are capable of being done in the browser like explode. So has anyone played around with WebGL or Canvas APIs? There's a lot of cool, this is a Chrome experiment using the WebGL to do 3D visualization in real time in the browser. We're already seeing tons of like new games being done in the browser, new 3D experiments, VR. I think the capabilities of what's being done in the browser is only going to get more intensive, and the needs of utilizing multiple threads is going to become more and more important. Already today, there's tons of libraries that utilize with like WebGL and Canvas that allows you to use threads to handle really intensive processes. I think that we're going to see more and more of that as well. Okay, cool. So other thing too. So actually, I think we'll get to that in a second here. So let's just do a quick recap on here too. So when not to use them. Web workers, as you've seen, are pretty heavy. Let's take a look at that code again. Right, because utilizing mirroring displays is like great, or like using separate displays because I have like my own separate presenter stuff on here too, but I also can't see at all. It makes it hard using a separate screen. This is our web worker one, our web worker example, and let's take a look at our slow example again. This is it. Utilizing multiple threads can be extremely helpful for making a better user experience, but you should be aware that you're getting additional overhead in just lines of code and trying to handle those multiple threads, and also cognitive overhead for your application. Like we said earlier, handling single threads really makes a lot of sense, and like our brains are really naturally good at handling that, easy to debug, et cetera, et cetera, et cetera. But multiple threads can complicate stuff a lot. So just be aware that if you're choosing to pull that in, try to make sure that you're like willing to take on the overhead too. Another thing I see too is people asking things like, what can we use this for, like the fetch or Ajax or whatever. It's good to understand as well how the event loop works in JavaScript, or that single thread works. So the event loop runs on a single thread, but a lot of processes actually work asynchronously, which means it gets spun off of the main event loop, and then once that callback gets returned, that'll join the event loop again. So things like database retrievals with Node, or hitting an API, right? Like the browser is not blocked while you're making an API request. It just like spins it off the main thread and waits for that data to come back before it spins that back into the main thread again. So utilizing it for things that are non-blocking CPU events, probably not a good use case for it too. You also probably want to use, like, if you're maybe doing like a image processor, you don't want to spin up a web worker for every pixel in that image. That's probably also not a good use case. Most computers don't have 3,000 CPUs available for you to do work on too, so you want to make sure you're like keeping that all within. I think Chrome is already famous for being a resource hog. If you're writing applications too that are going to become massively client-side heavy, just be aware of what you're doing to your users as well. Okay, great. My mouse. So, web workers, heavy, awesome, great for use cases where you're seeing things that are blocked, and they're hard to manage. Personally, too, I would put this web workers. Every time I've ever utilized web workers IRL, I've not prematurely done so. You saw my talk yesterday. I'm really big into, right, if you've heard the idiom, premature optimization is the root of all evil. Don't use web workers unless you need them. So if you're building code out and you see that if things getting really intensive and it's blocking the main thread and becoming a problem, or you're hearing customers are complaining about this new feature you implemented that's blocking the main thread, I think at that point you want to readdress how that works and maybe start looking at web workers to maybe fix that problem. But if it's not a problem yet, I probably wouldn't utilize web workers unless you really need it. I busted them out really as a last case scenario for fixing shitty code that I had written in the browser, or really intensive code in the browser. Cool? All right, cool. Also, too, if anyone says that JavaScript is a single-thread language, you can tell them they're wrong. I didn't get into this at all in this talk, too, but Node now supports multiple threads, which is kind of weird because it used to be like Node's thing, was that it was a single-threaded language. I think at version 12, 11, they're starting to beta test multi-threading capabilities in the. Yeah, I've seen some shakes. I don't know what the hell they're thinking, but whatever. It's just me. I don't know. Whatever. I don't know. Yeah. Okay. Cool. Also, Node 2 is not, the event loop is single-threaded, but again, if you're making like database calls, whatever, that's spinning off separate threads. So weird misconception of JavaScript. Okay. That being said, any questions? Any other follow-up questions? Yes. Question front.
So you said you've added in some of your projects. Have you handled the case where the browser doesn't have web workers? We call that.
Then I just use a single thread.
Yeah.
Yep. So yeah, then it's like, whoops, sorry, it's just gonna block.
Yeah.
Yep. Good question.
What would be the best method to pass data in a file that's
Yes. Wait, Jeremy, what was the name of the function again that you could pass data through to the function or to a thread? Was it
Are you talking about window.postmessage?
Is it post message? Yeah, I gotta look it up.
Let me look it up.
What?
Window.postmessage that safely enables cross-working communication between window objects. Between page and pop-up and spawn or between a page and an
Oh, gotcha. So from the main thread, you could do like worker1.postMessage, and you could send data back through that main thread. Yep, absolutely. So you could send like parameters or update data or whatever. You could send that up to them. Yep. Absolutely. JSON file, whatever you wanted to pass through there. Yep, absolutely. Cool. Cool. Yes, question in front.
You mentioned that workers can't access the window object or the DOM.
Yes.
Touch the accessibility tree.
I do not think so, because the accessibility tree is attached to the window. Is that correct? I'm pretty sure that it won't be able to. Yeah, that's a good question. So I think your main thread would still have to be handling like, kind of. Can you access the accessibility tree from like via the DOM API or whatever?
Yeah, and Shadow DOM is a big one.
Okay, cool. Yeah. So you would not be able to do that from a thread then. You'd have to do that from the main thread. But you'd like go do some data and then have your main thread handle making sure the accessibility tree is tip top or whatever. Good question. Any other questions? Awesome question. I'm shocked actually. Yes. Yeah. Question over here.
Can you communicate from one worker to worker?
Yes. Good question. So the question is, I should repeat the question so we're going to hear it. The question is, can one worker thread talk to another worker thread? Kind of. So worker threads can't communicate with each other directly, but you can send a message to the main thread and have that communicate to another thread.
There is a post message method on the worker interface itself.
Yes. So like, I think I can show you kind of what that looks like. Also, I don't know what this is. Okay. Blah, blah, blah. Let's take a look at my thing here. So the post message, I think you can do in the main thread, you could do like window.postMessage. This is an example of in my thread posting a message to the main thread. And we're receiving that with this on message thing here. So you think you can do like worker.postMessage from here to send data to whatever. And if I was going to do something here too, like I could do like worker1 and worker2 and spin up multiple instances of that worker. So we could set 2 threads running concurrently in the background. And then I could do things like I could send messages just to this worker1, and I could do things differently with worker2. But I have access to interacting with each of those independently from the main thread. Yeah, question.
You then send the reference for one worker to another one.
Ooh, good question. I don't think so because, well, maybe. I don't think you'll be able to do any work with it. Ooh, because that's weird, because the worker exists on the window. But if you send over a reference from the main window to a worker, ooh, that's weird. All right, should we try it real fast? Let's try to break some shit. Maybe we'll do like, dude, I don't know what's gonna happen here. So let's do worker1. Let's try to do. I have no idea if this is gonna work. Post message. Okay, first of all, I'm just gonna see if I can see this from here. Okay, and then let's go over here. And then I wonder. Ooh, I have no idea how that's gonna work. I'll have to look it up. I don't know. Maybe we can play with it afterward. My gut's saying no. I'd hypothesize no. But if you instantiate the reference in the main thread, you may be able to pass that through. But that seems really like not a good pattern to follow. I don't know. Yeah, let's play with it afterward. That's a great question. Cool. Any other questions? Any other questions? Okay. Cool. We're wrapping up a little early too, but I'd rather have you guys like not bored to tears while I stretch this out for a fall. Wrap it up a couple minutes early here. But before we leave, first of all, I want to say thank you, everybody. You guys have been awesome. I'm shocked. You guys are like asking awesome questions and like getting involved with code, which is super cool. For like the last session, on the last day of the conference, I've actually never experienced this ever in my life, so that's awesome. Kudos to you, they're an awesome audience. Secondly, too, I'm just going to do one last call out here, too. I'm going to be posting the slides and the video and a bunch of these resources on my Twitter, so if you want to follow along there. And again, I'll be posting this, too. This is linked to the code that I went through today if you want to jump through that. The slides, I would check out the MDN web workers documentation too if you're going to be interested in doing this. And yeah, that's it. So anyway, thank you everybody. Okay, cool. I think that there's a closing keynote next door afterward.